Hello everyone, thank you for listening to this session about innovation towards all-scenario converged storage. I'm Alex Zhang from Huawei IT product line. Nowadays, a lot of enterprises is doing digitalization to make sure that they can do a better business in the digital future. For this one, in the IT technology itself, we have a lot of thinkings. The first one is that we must build a good resource pools. In this case, we can provide the capability for different types of services, while we can do the resources pooling that make sure we have just provided the better and filterable resources. But when the data is becoming more and more, we need the intelligent data management for this massive data increase and the complexity to make sure that we have a better performance, efficiency, and lower cost. And in future, we will have different types of service applications. So make sure that we should satisfy current on-premise types of solution, but also capable to support in future the private cloud and the public services. All this kind of application must be capable to be served by the one unified data storage foundation. So today I will share with you Huawei OceanStor, how to embrace a digital future with one storage solution. We have Huawei OceanStor storage products, and also we have the data management engine. With these two, we can provide this kind of one storage solution for our customer. We have already been known as the main storage vendor because of our star products. For example, the OceanStor Dorado. It is for the mission-critical data storage. But also we provided the market with the OceanStor Pacific. It is for the large-scale unstructured data. So it's a distributed storage. Beyond this kind of main storage, we also provide you the data protection solutions. We call it OceanProtect. These are our star products. How we can satisfy you these kind of product and solutions? We cannot just offer you products in a silo model. We also need a very comprehensive design, innovative design to support different kind of requirements in the future. We can support the diverse hardware platform to provide you the high performance, high reliability, scalability, and reliability. On this one, we need to build a unified software to capture this kind of difference between hardware. And then on top of that, we need the innovative architecture to satisfy different kind of application and app-layer solution requirements for innovation. So today I will introduce you different kind of solutions from us. The first one is the OceanStor Dorado offline storage. We are now shipping these cutting-edge products worldwide. We have the most leading performance is 21 milliseconds of IOPS, and also it is low latency to 0.05 milliseconds. This is a further improvement on top of our 0.1 milliseconds when we released this product in 2019. This is already improvement compared to that. And also, we have the most powerful reliability. We have a 7 nines of reliability. Compared to the industry, it's mainly 6 nines level. It is much beyond the industry level. Not only for this kind of high-value structured data, we all know with the AI technology is developing, we need more and more unstructured data. So we'll provide the OceanStor Pacific series storage to make sure that we can host this massive unstructured data with an optimal way on the cost effectiveness. So it can reduce a lot of cabinets, saving a lot of spaces, saving a lot of storage spaces because of the data reduction and because of the high density of the hardware design. This is 20% lower cost per bit we estimated to provide it to our customer. But not only this kind of main storages, we also provide these full lifecycle solutions. In this case, it's not only the production with OceanStor and the analytical application with OceanStor Pacific. We also need for the backup and archive solution. We call it the Ocean Protect. So in this case, we can host the hot data, warm data, and cold data in a more proper way. We build the solid data store foundation with end-to-end application. But we could not just provide the product. We give you one converged foundation. So we build this OceanStor OS to be the software platform for all these kind of products. It can host diverse hardware matching, different kind of computing power, different kind of network solution like fiber channel, IP, or different media with a hard disk, solid disk, and also the storage class memory. It can provide you the high IOPS, it can provide you low latency, it can also provide high performance, but with strong reliability. How we can do this one? We need the innovative architecture. For example, on the high performance, we have the flash link technology. It can have this kind of end-to-end computing power. It's not the computer is not only on this controller itself. It's also on the SSD array disk enclosures. Also, in this kind of each disk itself, SSD disk itself. So with the end-to-end computing power, it can know the data format inside to have end-to-end performance optimization to make sure there's no performance bottlenecks. And based on this powerful processing capability, we can offload a lot of processing workloads from controller to the SSD itself. And then we build the end-to-end NVMe architecture, can provide you the 30% lower latency. And not only this one, we also build the AI algorithm to make sure that we have higher caching ratio to make sure different kind of scenario we have the best cut-in performance. Beyond this product itself, we can also need to focus on the data center level. So the data transmission, we have the joint innovation with Huawei Cloud Engine team. So this NVMe over RoCE technology, we can build the latency to the 50 microsecond level. So in this case, we can bring 58% lower latency and 2 times more IOPS. So it's a further step. On reliability, we build the world's most powerful reliability. It is with smart matrix architecture to the 9/7 reliability. It is because within the 8 controllers, we can tolerate up to 7 controllers failure. With different controller enclosures, we can tolerate 1 controller enclosure totally failure. So in this case, we can have the minimal fault domain and have the global load balancing to make sure that you have reliable foundation of data. Not only on data center level, we also need more reliability between the data centers. So Huawei has the true active design with the hypermetro design. So data center 1 and data center 2 is all active with applications. But when there is a failure, the service level application active high reliability can make sure that there's 0 service interruption or data loss. This kind of distance are even up to hundreds of kilometers away between the data centers. It can have the automatic failure recovery. So the application level has no impact because of this. And high scalability is another checking point. So we have the distributed software architecture. Compared to the previous, we must build different kind of scale out for different kind of services like block, file, object, big data. We have one unified global storage pool. So we can bring all these different kind of workloads on one storage pool. And so in this case, we can do hybrid workloads. So to make sure that we are easy to use, and then this one can be easily scaled out to about 4,000 nodes per cluster. So in this case, we can build to satisfy the data expansion requirements. Not only for the storage itself, in the data center level, the storage must work together with computing resources. Previously, when you need to have the bottleneck on the computing or storage, you must scale out the whole resources because it is a coupled design. But right now for the data center, we believe the decoupled storage and compute architecture will build an elastic data platform for all the customers. Why? It is because the computing technology, which is more based on CPU, NPU, the computing technology, it is only have 3 years life cycle. But the storage part, because of data life cycle, it's very complex. We many of time have 5 years or 10 years life cycle. So we must expand the storage and the compute because separately because of the life cycle differences. But also, we need to eliminate the restriction that the expansion must be done together. The one there is a computing demanding application. We can expand compute resource easily. But there is a storage demanding application. It should expand the storage separately, not in a coupled way. Even if we need to upgrade our storage, Huawei OceanStor solution has one design. We call it the flash ever. So in that means we can upgrade the storage separately by the controller enclosure and the disk enclosure. In this way, when we are upgrading controller enclosure, the disk enclosure is not touched. So the data itself, no need for the service interruption or data migration. If we upgrade the disk enclosure, and then the controller enclosure will have the data in reconstruction automatically. So in this way, there is migration-free of the solution for 3 generations in 10 years. So it's hugely reduced the complexity of the data migration scenario. We have all this kind of product solution itself, but many of time we need to manage this platform in a more easily way. So we build a highly automated with three-layer collaboration intelligent data management platform. We build the AI capability in the device level, in the data center level, and in the cloud level to targeting the intelligent data tiering to make sure we have a pool for the storage resources. And also to do the intelligent data mobility, it is to satisfy a lot of scenarios. It's driven by services difference, data protection requirement, user experience requirement, and the cost requirement. And at the end, we need to improve the intelligent data O&M efficiency. The first one, intelligent data tiering. We can put all different kind of storage into a pool. But it's very hard to understand from the different kind of application in which tier it goes to, what kind of SLA it requires. So the DME have the capability to build in the workload identification. Based on this kind of automatic identification, it can do a better workload clustering. With the clustered workloads, it can meet into the different kind of tiering, and then the DME will automatically put this data storage into the corresponding storage products. Either it is mission critical for OceanStor, Dorado, or Flash, or it is massive unstructured data on the OceanStor Pacific, or it should be in this backup or archive. So it's all automatically done. So the TCO will be 30% optimized. It can do the resource aggregation and sharing. Many of the time, the utilization ratio is 40% in the carrier IT platform. But right now with this DME, it's proven will be 70% of the resource level. That is tiering and the pool. But there is a way to optimize how we make the data storage. We should put the data into the most suitable storage itself. Then we have different kind of floating requirements. Either it is life cycle driven, because it is from old legacy storage to the new storage, or it is driven by the business process. For example, the video surveillance data from edge to the center, or it is tackles prediction, precise marketing, need the data from BSS domain into the data analysis domain. And also, there is a business protection driven requirements. It's a snapshot, local backup, intracity active design, 3DC data recovery, this kind of thing. Even better way, we want it is user experience driven or cost driven. When some of the data is no longer hot anymore, we want to put it into the backup or archive. So this is cost driven. So with the intelligent data mobility, we can do the better efficiency utilization than to make sure that the DME can help this kind of data flow more easily. And for the intelligent data mobility, it also have one very typical way is that operation migration. In the migration, it's very complex and heavy job for the maintenance people. We need to evaluate, we need to plan, we need to implement and check. But with this kind of DME support, with the infographic tools, migration design tools, we can do 90% of efficiency improvement. And this is for the daily operation. But how about the fault management? If the data is increasing 10 times more, 5 times more, how can manage? So we must utilize this DME to optimize it. So right now, we have the capability to support people, one person to manage 50 sites of storage, compared to previously only 10 sites of storage per person. Because it can do the disk fault prediction 40 days ago, ahead. Performance trend prediction 60 days ahead. And capacity trend 1 year ahead. This is to improve the efficiency. In future, the enterprise digitalization will have multiple application scenarios. It could be on-premise with this virtualization based on VMware virtualization or OpenStack. It can be also a new technology like Docker. And also we need to leverage the public cloud application. So this story must have the one framework to fit in multi-cloud scenario. So this is also part of our capability. We can have the standard interfaces toward different kind of application. So we believe with these innovative products and also with the intelligent data management, we can provide you the cutting-edge solution. So we have already more than 8 years R&D in this domain, and right now we have been well known because of our R&D innovations. We are recognized by the third party to be a global data storage market leader. So we hope that we can have the opportunity to cooperate with you together. Till now, we already have 12,000 global customers. We believe with your support, with our continuous R&D, we will embrace the digital future together. Thank you for your time.